At the end of the lesson, you are expected to identify outliers in one-dimensional data, describe indications of anomalous behavior, and appreciate the use of these indications in anomaly and fraud. In the real world, we do not actually deal with uniform or normal distributions, and this kind of situation actually gives a lot of challenges to data scientists, especially when we do anomaly detection and fraud. In most cases, our data can be very much irregular. Sometimes we could see this kind of distribution when we plot our data. And this usually happens when we do the log transformation of a data set, which is really very irregular. And this situation is actually very much better than when we are faced with this kind of distribution. This scenario can be a log normal distribution or a gamma distribution, wherein there is a strict lower bound, which can be on the right or it could be on the left of our distribution. But sometimes the problem is this: how are we going to define data points which can be considered anomalous or not? Because if we are going to examine this kind of distribution, a very long tail may pose a big challenge to our identification of anomalous behavior. So the question is this: what are we going to do then? There is a very good solution when we are faced with this kind of situation. So when we have a known nature and characteristics of our data set, all we have to do is that we're going to set a threshold. We actually had this one in our course, linear regression, wherein we set a certain threshold for us to be able to identify at what particular point we can consider our data to be normal or not normal. So in this case, domain knowledge is really very important in identifying the normality of our data. So for example, when we set our data to have a 1% to be considered way beyond what is normal based on our experience, based on domain expertise, then 1% is our threshold. So if you could still remember in our data set in linear regression, in our data, we have set 1% to be considered not normal data because they show abnormal characteristics. So then, in unimodal distributions, what then would be the indication that certain points would be considered anomalous? So we have to take note of this one. A certain collection of points can be considered anomalous if their number is larger than predicted with the statistics of our distribution. Say, for example, when our data points are just here and our predicted points are just here, so then we can say that these points, because these are higher in comparison to this predicted value, then we can consider them to be very anomalous. After these unimodal distributions, what then is the situation when we have a multimodal distribution? So unlike this one when there is only one mode, in this case is we have more than one mode. So the data distribution can be like this. So this one poses a great challenge, even greater than the first one. So here, what we have to do is that we're going to discover the data very much closely, because without this close examination, we then have a very impossible understanding of what data we have and what kind of behavior we can consider to be anomalous or not. So in this case, it follows heuristics, which means that we have to discover or learn something for ourselves. If you could still remember before, we have said that in some cases, we have set three standard deviations to be the boundary line between normal and not normal. And beyond three standard deviations, whether it be from the left or from the right, can be considered anomalous. But in this case, because it's heuristics, then this kind of technique will not give us the proper solution to a multimodal distribution. So what we have to do is that we're going to understand the clusters of our data points, because it is always better as far as multimodal distribution is concerned to think that our data is consist of a lot of clusters of data. And from the clusters, we would be able to understand the anomalous tendency of the behaviors for a certain cluster. What is this for? Why do we have to study this? When we have quantitative data, we usually analyze the statistics using distribution. With this distribution, we are able to understand the indications of anomalous behavior. After all being said and done, let's try this. How do we identify anomalous points in unimodal distribution? What is the challenge in identifying anomalies in multimodal distribution? Please write your answers in the comment down below so that we would be able to have a very rich interaction of ideas and we can learn. Do you want to know more about this channel? Just click these cards. We do have a lot of free data science courses for free like Machine Learning Essentials, Deep Learning Mathematics, and a lot more. Here, you can always learn an upskill for free.